Hello and welcome to the AIM webinar series. AIM is the global industry alliance for stakeholders of barcoding, RFID, and other automatic identification and data capture technologies. Our stakeholders include manufacturers, software vendors, distributors, integrators, resellers, governments, and end users across all industries who depend on accurate, available, and identifiable data. AIM creates standards, promotes community, advocates, and educates. Before we get started, there are a few housekeeping items I would like to go over. First is our antitrust policy. It's the policy of AIM Inc. to conduct its operations in strict compliance with the antitrust laws. No AIM activity shall create even the appearance of a violation of the letter or spirit of the antitrust laws. Next, we have AIM's collaboration and work product policy. This states that presentations like today's are held for the primary purpose of advancements in our industry, which necessarily involves development of work product intended solely for the public domain. AIM has developed this policy for the protection of its members who engage in this important collaborative effort. And lastly, before we get started, attendees are muted throughout the presentation. If you have a question, our presenter will be answering some of those at the end of the presentation. You can ask questions by chatting those to AIM Member Services. You will also be notified when this presentation recording is available. Today, I'm here with Ryan Morris, who is Market Product Manager at SICK. Today, he will be discussing things to consider with RFID being a part of your logistics operation. Ryan, welcome and take it away.
Thank you, Mike. So again, good morning all, or good afternoon if you're on the East Coast. My name is Ryan Morris. So I've been with SICK here for about 4 years, responsible for our machine vision and our AutoID products, whether that be laser scanners, image-based readers, or RFID, which we'll focus on here today. So again, I've been with SICK for about 4 years, but been in the automation space for about 10 years now in some various capacities. So today we're going to speak about RFID, specifically in the future of track and trace. I'm going to cover a couple of different technologies, what RFID is, some applications, some kind of installation and considerations, and some of the global aspects of RFID. So for those of you who are not familiar with RFID, so what is it? RFID stands for radio frequency identification. So unlike any other auto-ident technologies, RFID uses a antenna or an interrogator, and as well as like a controller to control that antenna. And then our RFID transponder or tag or smart label, they go by quite a few different names. But the RFID will use the antenna basically to provide power or reading field to an area and read that tag. The typical technologies that we see in RFID would be high frequency or also high frequency, the two main technologies. And with that, and we'll discuss both those technologies here in a brief moment. But with those technologies, what kind of goes on is the radiation from the RFID reader provides that means for communicating with the tag and the interrogator, the reader itself. And depending on the tag that you're actually using, the tag may actually provide and gain that energy to actually power up and communicate from the field itself. And that would be kind of a passive tag, and we'll discuss active versus passive here momentarily. So that's basically what's going on. So unlike laser-based systems where you're using a line scanner to identify a 1D code or image-based code readers that are using an area camera to identify 1D, 2D codes or OCR codes, RFID is basically just interrogating an area over a frequency channel to activate and read or write data that is on an RFID tag. There we go. All right, so why use RFID solutions over the traditional AutoID technologies? A lot of the limitations to traditional AutoID technologies, obviously being one of the major ones being needing a direct line of sight, or in an instance RFID needing to write real-time data to a tag. Obviously with traditional barcode labels or QR codes, data matrix codes, not able to write data on the fly or store additional data to that code. RFID obviously provides the means of being able to write real-time data and store that on board a tag, as well as no longer needing that direct line of sight with a label. Benefits of that obviously being, especially when you get into want to track packages or track items throughout different enterprises, different areas throughout a facility. Obviously, a lot of wear and tear, dirt and dusty environments, damaged labels can really be an issue. RFID really kind of provides some protection against any kind of labels being damaged, being able to do some more bulk inventory analysis. So think of like inventory processes inside of a warehouse trying to inventory what's on the shelves. AutoID or traditional laser-based or image-based code readers are really going to have an issue trying to do any kind of bulk inventory analysis in there. Whereas RFID is able to do upwards of 100 tags a second, being able to interrogate a space to actually do some inventory. It also provides a lot larger reading fields and dimensions than traditional AutoID technologies. Typically, especially in the ultra high frequency world, you're looking at 10 meters or so of reading range. So you can get quite large reading fields that obviously a traditional AutoID image-based or laser-based scanner would not be able to provide as far as being able to get those kind of read ranges or working distances. And then obviously there's a lot more global standards being driven now, especially in the ultra high frequency world, that really provides some data protection and enables that cross-enterprise tracking of RFID tags throughout the world. So kind of getting into the industrial versus commercial RFID. Again, for those of you who aren't familiar with RFID, I'm sure you guys have all used it, whether or not you know it or not. Typically, a lot of the commercial RFID is probably what you see in your everyday day-to-day life, whether that be a security card access point to get into your facility or to get into your hotel room. Typically, that'd be either a low frequency or a high frequency RFID reader. And that's probably what we see most often, or a lot in our everyday life, those commercial RFID readers. Obviously, it's using the same technology. However, it is not nearly as robust as an industrial reader would be. For instance, you go up into your hotel room door and you try to open it. You can have multiple seconds or multiple tries at trying to get your door open, and it's not going to be a big deal because you have time and you can account for a misread, where that's just not an issue. Industrial, however, really needs that reliable reading. It needs to read a tag the first time, every time. So it should not miss any reads, and it doesn't have the time or the luxury of being able to have multiple inventory rounds to be able to identify a tag in a field. So that's where I see obviously the industrial readers being more obviously in the industrial spaces. A lot more rugged design, more resistant to noise, more resistant to noise. Can interrogate at very fast speeds, especially for production environments in the logistics world. Longer range reads. So again, with those low frequency and high frequency readers, you're very defined by its inductive field. So you're really looking at a few inches to maybe out to a foot as far as reading range goes. So obviously industrial readers will provide a lot longer read ranges. And obviously support for common internet protocols. So whether it's Ethernet IP, Profinet, Ethernet TCP IP, serial, a lot of those different industrial protocols can be used, especially if you're trying to get the data from a tag up into your ERP system. So, Mike, I'm going to have you click a couple times here. So physical basics, again, kind of discussed it here, but obviously the RFID is emanating or irradiating a radiation field. As that radiation field is activated via a trigger, it would basically inventory and see what kind of tags are in the field. Mike, if you can just click a couple times, please. So as we're broadcasting that data, we're reading data or that is stored on the tag. So I would say about 90% of applications are probably strictly that, where you're just looking for a tag and you want to read that information that's on that tag. As you saw there kind of briefly there, you can also actually send data to it. I know it comes up quite a bit. Why would I ever want to send data to a tag? Why can't I just read the tag data and send that information up to our ERP system and kind of do any kind of tracking that we want to do that way? Obviously, for sending data to a tag itself, you can obviously store it locally on the tag, so it can be read by maybe a separate ERP system or a separate enterprise that wants to read that data off that tag as well. So what kind of information would you typically send? Typically more process information. So say tag's going through the field and you want to write what time it actually came through and store that on the tag. You want to know what truck it got delivered onto. You know, what facility was this that this tag was or this package originated from. So you can send a lot of data to it, whether it's a timestamp, whether it's a process. Hey, automotive world, this is going to be a red car. Here's the VIN number on the car. So you can send a lot of data to it. But I would say it's probably typically about 90% of applications are probably just read only. However, you want to store data locally onto a tag and have that field be read across enterprise. Maybe it goes on to the next station where, again, I'm just using automotive again for an example. Order comes in, car needs to be read. You send that data to the tag, say, hey, paint this car red, gets to the paint line, and now the next RFID reads that it needs to be red, and it knows exactly which color to actually paint the car. So again, a lot of those one-offs or those on-demand single order scenarios. Oh, and then obviously receipt all that data too. And click again, please. All right, so again, some solution considerations. So what do I need to consider when I'm getting, this is kind of going into any kind of AutoID application. You know, what are the requirements? Again, is it going to be RFID? Is it going to be laser-based scanners? Is it going to be image-based code reader? What do I actually need to do? Are there standards I need to consider? What's the best product? Again, what technology am I looking at? Integration work, you know, how difficult is this going to be to integrate, especially into your ERP system, or trying to select the right tags if you're going to use an RFID solution with the transponders. And then what frequency? You know, there's a lot of different frequencies out there in the RFID world. So which frequency is going to be best for this application? So kind of getting into RFID versus the other AutoID technologies. Obviously, you can see there's a lot of overlap as far as read ranges and, you know, what kind of labels and tags you can actually read. So obviously, optical, laser, and camera-based has a lot of overlap there. However, you start getting into the RFID world here now, and now you can just see some of the additional features and benefits that you might get from using either one of the HF or UHF technologies. So again, UHF, very long-range reads that provides that over that HF technology. Omnidirectional, that's always a big one, especially for 2D barcodes or 1D barcodes, you know, being able to have a omnidirectional read where the camera-based obviously thrives there. However, you know, you get into the RFID world as well, you start to hear about linear antennas or circular antennas. You need to read a tag in any orientation. So orientation does matter depending on the antenna that you have. Obviously, no direct line of sight. That's true for any RFID solution. Obviously, read-write data and maintenance free. So again, no cleaning, no printing of labels. Don't have that restriction that a traditional camera or laser-based reader would have. So again, start to get a lot of different benefits to go into an RFID solution. Obviously, the fact of being able to have no direct line of sight, being able to read and write data real time on the fly, bulk reading applications, and obviously that no direct line of sight capability. So applying to RFID to your application. Again, a lot of similar questions that you might want to ask yourself in regards to any kind of AutoID solution. You know, where does this read have to happen? What's my reading range? What's my reading window? What type of tag do I need? Is it going to be, instead of being a 1D or 2D code, and how much data I need to have in that code? You know, what's going to be, does it need to be a high temperature tag? Does it need to be a high memory tag? Do I want it to be disposable? Is it on metal? Do I need something very custom, whether it's maybe tracking a shirt, you know, and I want to have an RFID tag be in the button of a shirt. So there's very specialty tags out there. So there's a lot of those type of questions. And then just as a consideration, obviously, if anybody's in that AutoID world, they probably see a lens chart as far as, you know, working distance and lens focal length and field of view, expected resolution of the cameras and whatnot. So you can kind of get a general idea of what your field of view, working distance, and code resolution could be. AutoID, or I mean RFID's charts, there's charts out there as well as far as reading charts. They don't look nearly as linear or graphic as that. But I'm showing a couple of charts on the right here as far as what kind of radiation pattern you'd expect. And you kind of see the top one there. It's a that's a UHF radiation pattern. So instead of seeing read ranges, you're seeing power. And so what that kind of means there is at 0 degrees, so dead center in front of the reader, you'd expect to see max power. So if you have a RFID reader that's rated for 2 meters or 10 meters, that's kind of what you would expect to see at 0 degrees. Now, as you follow that bubble around from 5 dB dead center to, say, plus or minus 45 degrees, you drop 3 dB. So you go from 5 to 2. So what that means now is instead of having full power, every 3 dB drop, you'd expect half power. So your read range would actually drop in half at plus or minus 45 degrees from the center of the reader. And then again, next 3 dB drop at, I can't really see here, maybe 90 or 75 degrees, you'd expect about a quarter power. So you're dropping half from half. So you really see what kind of read ranges you would actually expect based on your angular position of your tag. HF, however, since it's a very inductive field, is a lot more defined. So you actually will see some ranges depending on your RFID tag types, the size, the physical size of your RFID tag. You can kind of see what kind of ranges or what kind of read ranges you'd expect to get out of a certain size tag. So I kind of mentioned this very, very briefly on one of the first few slides, but another consideration that you might have as far as RFID and tag selection goes is you might hear active versus passive RFID. And what does that mean? So active is basically battery powered. So the tag itself is not getting energized by the field. The tag itself actually has its own power source. So that would be obviously a battery. Kind of think this is maybe you have an easy toll pass in your car, which is an active RFID tag. So there's RFID readers at all those tolls, and they'd be reading your tag that's in your toll or your active tag in your windshield. Obviously, some of the downfalls to it is there's a battery, so it's going to be a little more expensive as far as a maintenance standpoint. You're going to have to maintenance that battery, but you will be able to get longer read ranges. So that's why you see a lot in the toll marker or tolling, is you're looking for a longer range read. But again, there's some service, there's more cost to it. In the industrial world, we do see a lot more passive RFID, strictly because, again, it is a less expensive tag. So you have a lot more options out there as far as form, fit, function goes. Again, less price and less maintenance because you don't have to provide that battery power to the tag. So the passive RFID tag actually gains its energy for communication and transmitting data over the RFID field, so it does not require that battery. All right, and here's just a quick little slide, just some of the examples of tags that you might see out there. So again, there's a lot of different tag manufacturers, a lot of different types of tags that you can see. But yeah, I mean, obviously logistics and packaging, you might see a lot of more adhesive tags out there. So just a sticker label, you have an RFID printer that's just printing off RFID labels that to put onto a box. Obviously in the automotive world, you might see a lot more of these screw rivet types where you're having an on-metal tag that is physically bolted onto the car itself. Obviously, being an on-metal tag, really long-range reads that you might see there. Otherwise, you see quite a lot of cable ties or maybe embedded tags and molds that might be tracking molds for how many times that mold has been used, or what mold it is for a specific tooling application. And again, as I mentioned, some specialty screws as far as like the sew-in screw, like if you want a button on your shirt, if you want to track that in a retail setting, you want to use that RFID tag for pricing or something along those lines. So just jumping into the technologies here, I'm really going to more focus in on the HF and the UHF technologies. So those are the two main ones that we definitely see in the logistics and just kind of the RFID world in the industrial world. with more of a focus on the UHF RAIN technology, just because that's kind of where we see the technology going as far as Industry 4.0 and be able to track and trace items throughout the entire supply chain process. HF obviously has its benefits, as far as it's very defined reading field, very close range reads, however. So it's a very inductive field, which we'll discuss. So it's very defined. It is what it is. You're going to get about, maybe a few inches out to a foot, and that's going to be your reading field. However, because it's very defined, it's very inductive field, it's obviously not as impacted by the environment, we'll say. So again, if there's water in the environment or, metal in the environment, metal obviously will reject that read, and you're not going to be able to read through metal. But if there's water in between the tag and the reader itself, that won't affect your read ranges at all. However, it's a very slow reader, or a very slow process. I mean, it requires parts to be stationary or very slow moving. You're not going to do any bulk reading applications because, again, it's just a little bubble or a little reading field of a few inches out to a foot. So you're really going to see only a small area. So you're not going to do bulk reading applications. Whereas UHF now provides the capability to be able to read very, very far out to 10 meters. However, or you could be very, very close. So because I'm not an inductive field anymore, I'm actually controlling a power or a radiation. I can read out to 10 meters with a unit, or I could have that power dialed all the way back and only read a couple inches. So you have a lot more flexibility as far as what kind of ranges you actually get with the UHF technology. It's also very fast compared to HF. So again, especially those logistics applications where packages are flying by, you need something fast, and obviously they're in motion. So you need to be able to read in motion. Again, I mentioned bulk reading, so being able to read upwards of 100 tags a second. However, there was a couple of considerations we needed to consider. Water influences. So if there's a lot of water in the environment, that kind of dilutes the reading field, so you're really not going to have the energy anymore to power up the tag. Metal in the environment can act as a reflector. So if you have a RFID reader really blasting out a lot of energy, you're going to get a lot of reflections off of metal. And obviously, because of that, you might get some overreaches. You might start reading tags that are outside of the reading field that you really don't want to read. So something just to keep in consideration is metal will kind of reflect. And then obviously regional considerations. So what that means is there are some regional, depending on the country or country that you are operating in, there are RFID readers that are specifically approved for individual countries. Whereas HF is more of a worldwide approved reader, so you can use any kind of HF reader in the US or Europe or China, and there's no radial approvals that you have to worry about. So getting into those. So again, HF, governed by ISO 15693, can be used worldwide. UHF, there's two main bands for UHF. There's ETSI, which is kind of the European government or regulation organization. And then there's the FCC, so obviously in the Americas. So you kind of see the dark blue versus the light blue. All that really means is the RFID reader itself is broadcasting on a different frequency. So you can see the ETSI, it's 866 to 868 megahertz, whereas in the FCC, the dark blue countries, you're looking at 902 to 928. However, even though I'm just broadcasting on those two frequencies, it still falls within the UHF bandwidth range, so that 8 to 960 megahertz bandwidth range. So what that means is, as long as you have a tag that is operating like a global tag, so if I have a tag that can operate from 866 to 928, that tag can be read worldwide still. I just have a specific reader for the US, I have a specific reader for Europe, but the tags itself, as long as it's a global tag and not an FCC tag or ETSI tag, as long as it's a global tag, that tag can be read worldwide. So just kind of keep in consideration if you are machine building or anything along those lines and you have a RFID reader that's being built in the US but being shipped to Europe, obviously there's just some considerations to make sure that whatever reader that you have there is approved for that country of origin, or that country of operation, I should say. So just some considerations, but however, the tags themselves are global, so you could read those globally. It's just the readers themselves have different approvals that they need. So kind of get into that physical concept again here. So this is HF. I've kind of mentioned it is a very inductive field, so it's a very defined reading field. So kind of think of like a magnetic field, how you kind of see the magnetic lines there in the bottom right corner. So that's exactly what a HF reader is doing. So that's why, again, we have a very defined reading field, really based on that inductive coupling between between the integrator, the reader itself, and the tag. And you kind of see the overlap there. That's where you get your communication when the inductive fields overlap, and that's where you'll start to see the communication start to happen. So again, that's why you get a very defined reading field with HF, which is good. You know what it is, but getting into the HF world now, or UHF world now. UHF world, kind of mentioned before, unlike being inductive coupling, it's using electromagnetic coupling. So what that is doing is it's actually blasting out, transmitting energy through an entire field. So it's more like a light source, more or less at this point. So you're actually blasting out light or blasting out radio waves into a field instead of using an inductive field. As I'm emitting energy, any tags that kind of enter in that energy field now can start to use that energy from the field and start to communicate and send data back and forth. Things to consider again for UHF rain here is, since I am just kind of blasting out fields, and there could be different metals in the environment, different operating conditions, it is very imperative or important that you actually test your field out. Because of this, you can get a lot of holes, as you can see in that middle picture on the right there. You might have holes in your reading field where, even though it's within the range of the RFID reader, you might get holes, or you might get some overreaches, these little island bubbles over here. And that might be due to just, again, reflections or whatnot. So it is very important that you actually test your field to make sure that you're reading everywhere you would expect to read a tag. And then kind of get into the actual antennas themselves. So whether that's a circular or linear antenna. And really all that means is the tag orientation. So circular antennas allow for any kind of omnidirectional tags, whereas a linear antenna is very kind of more strict as far as the tag orientation themselves. So I'm kind of just elaborating here too. So as you can see on the left there, a linearized antenna, the tag orientation does matter. So just something to keep in consideration depending on what kind of antenna you're actually using. Linear really doesn't provide for that omnidirectional or any kind of orientation, whereas a circularized polarized field, instead of using a linear antenna, I'm kind of circulating the field itself. And because of that, allows for that tag to be independent orientation. So it can be in any orientation whatsoever, and you'll still be able to read that tag. So it's a lot more flexible of a radiation field when you have a circular polarized field. So again, just elaborating again more on the influences of the environment that you might have in just any kind of RFID application. So again, especially with UHF here, you get a lot of reflections. So you have your field itself, you have your energy that you're putting on the field. However, if there is metal, you might see that little red dotted line, how you get some reflecting off of that metal environment. And you start to maybe pick up tags that are outside of your defined reading field. Typically, obviously, we don't want to pick up stray or loose tags. We want to be able to read the tag that we're actually looking to read. And fortunately, there are some things that we can do about that, whether that be filtering or masking or adjusting the power that we're actually using with the reader itself. So I mentioned filtering. So the tags themselves will always have an RSSI value or a return signal strength indicator. So a lot of readers on the market will have some sort of filter that you can say, hey, if I have a really weak RSSI value, I know that's probably not a tag that I'm looking to read. So you can have a filter basically to ignore out everything that's lower than a certain RSSI value. So filter out overreaches that way. There's also some masking. So say the UII or the unique identifier for your tag, or a certain word that's in the user memory that you want to filter or mask out only tags that might have that certain word in the UII. So you can filter out tags that might not correspond to tags that you're looking for. So there are some, obviously some things or tricks that we can do to make sure that we're eliminating any kind of overreaches or eliminating any kind of double reads or continuous reads. So with some just standard filtering and power adaptation inside the reader itself. So again, so just kind of sum up here, just kind of, again, RAIN and UHF RFID itself, why we really see this more as the growing trend in technology as far as logistics or just any kind of industrial applications over high frequency RFID. Again, no visual contact. Obviously, HF still has that capability. It doesn't need that visual contact with a RFID tag, but obviously with UHF or RAIN, you can get a lot longer read ranges. And it's really independent of tag orientation now. So again, with those circular antennas, you don't need to worry about orientation. Bulk reading applications, whether that be you want to start doing inventory, or you have a box come through that might have 100 tags in it. You want to make sure you read all the tags that are inside that box to do some inventory control. Larger reading field and adjustable reading field at that too. So obviously UHF being very defined, or I mean HF fields being very defined, UHF, if again, if I have a reader and I want to read just a couple inches away, but that same tag needs to be read 10 meters away at a different point, at that point I can obviously have a reader that reads a couple inches, and I can have another reader that reads 10 meters and still be able to read that exact same tag. Whereas in HF world, you'd have to always be 1 foot away from the tag, which is not, technically feasible in a lot of these applications, especially when you're talking interlogistics and you're talking about transporting items from one location to another. You're not going to be able to be a couple inches away at all times. Global data standards, again, as I mentioned, cross-enterprise usages. HF world has a lot of proprietary tags in the world. So again, reader A at company A might be able to read this HF tag, but then company B has a different reader, and also they can't read that tag because there's a proprietary tag to that proprietary reader. So it doesn't really enable that cross-company usage in the HF world, because there could be a lot more proprietary tags out there. UHF or RAIN, however, it's more global standard driven now. So as long as it's a UHF tag, company A is going to be able to read that with their reader, and company B is going to be able to read it with their reader, because it complies with global standard now. So that's really kind of enabling that cross-enterprise usage of those tags now. So you don't need to specify a certain manufacturer at all facilities. You could use any kind of manufacturer as long as it's a UHF reader. It will read those tags, because they are globally driven by data standards now. Again, speed, a lot faster than HF, and obviously be able to read bulk tags in motion as well, where HF can't do that. And we also do have direction detection as well. Again, HF really is just identifying a tag in its field and sending out that information. With UHF, you have the capability of now being able to do some more directional information. So whether it was an inbound or outbound process, did that package leave, or did that package come in? Did that pallet or tote leave or come in? To travel left to right? Maybe I'm monitoring a tooling haul. Did that tool get checked out, or did that tool get returned? So being able to get some more directional information can really be crucial for your application environment that UHF can also provide. So again, what's the difference? Really for kind of logistics, or in the whole idea or concept of Industry 4.0, think of it more as a closed loop or open loop process. So HF, since again, it's a very close range read, it's not really cross-enterprise capable. It's going to be a very internal process, really. So you're going to be tracking maybe a tote or a carrier or a skid internally. It's a strictly guided process. There are very defined reading ranges of maybe a few inches. So that might be very, very acceptable for an HF application. However, we start getting to UHF, now we're on a tracking, maybe some of those same products, but read ranges are starting to get a little larger. We want to track that component from company A to company B. So we really have a lot more of an open loop process with UHF readers. So again, just some of the things that, again, what UHF or RAIN really enables. Transparency across the entire supply chain. being able to see a lot of the processes, from the upstream time processes to downstream processes, much longer read ranges. And again, those global standards in bulk reading are really a big one too. Now that we're able to actually track and trace tags throughout the entire supply chain, and you kind of see just the whole supply chain now. So think of it as it's showing here a lot of different scenarios. Again, assembly line from component A, maybe it's a item goes into a box. Your really small read ranges, limited space. You're looking at maybe sub-foot, and you may throw a UHF tag on there. Now that package goes into a tote, a little more longer, mid-range now, maybe reading out to about a meter or so to do a tote identification. And then that package or tote might go into a truck and go from company A to company B. Now I'm doing an assembly line, or I'm taking that box and I want to put it onto a warehouse shelf. So you might have a longer range read now that you're maybe tracking a tag coming into a loading dock. So you have longer range reads there at that point. Now maybe I want to do some inventory control and I want to do some bulk reading applications. So I have an RFID reader that's doing some bulk reading applications. So reading that from a long range and reading a lot of tags at once. And then logistically, now all of a sudden that package, that box leaves. Okay, did that package leave or did it come? I get some more transactional inbound, outbound applications, and then obviously the longer range reads there as well, so out to 10 meters. So again, that UHF story really shows that I can read that same tag from very close range, I can read that same tag from very long range, and I can read that cross companies, cross enterprises, and I don't have to switch out technologies, I don't have to switch out readers. All you really need to do is just adjust the powers that you really are transmitting on those readers themselves. And again, manufacturer independent as well. So you don't have to worry about, they're using manufacturer X, we're using manufacturer Y. We need to make sure we use the same one in order to communicate with the tags. You really have a lot more flexibility as far as form, fit, function, and features that maybe a supplier might be able to offer with their UHF RFID readers. All right, and just kind of summarizing up here. So obviously some of the big differences with RAIN UHF is longer read ranges, data standards, speed rate, much higher speed rate than HF. The bulk reading applications, up to 100 tags per second, and while in motion, and availability now. So again, UHF tags, there are definitely starting to go down in price now too. So the limitations into getting into the RFID world are dropping. So again, you're really not dependent upon a very high price tag or anything like that anymore. So they are just paper label tags potentially, maybe it's a penny a tag. So you can really, the cost of ownership or the cost of entry is definitely reduced down quite a bit in the UHF world. And again, just get your guys' minds rolling here a little bit, just some of the typical applications that we see with HF or UHF type of applications. Again, we see a lot of RTI or returnable dunnage. So whether that's totes or pallets or whatnot. Hanging conveyors is a good application maybe for HF or a short range UHF application. Very guided, strict process that you might be just tracking hangers coming around a conveyor. Access management. Again, a typical might be would have been a traditional commercial or light industrial type of application. But obviously now, if you want to really have a robust application, maybe you don't want to actually have a key card swiping, you want to just have a tag that might be in the windshield of your car that you're using that to monitor access control. So you can do a lot more of those longer range access management without having to worry about presenting a card. And then we kind of mentioned that Tote application as well. In the UHF specific applications now, that's where we really start to see a lot more, again, these bulk reading applications, whether it be a gateway, you need to read hundreds of tags, walking through a gateway. I need to know directional information. Maybe you're starting to talk about AGVs and AGCs and you want to do guidance. So you can embed an RFID tag in the floor itself and use some guidance applications. Hey, take a left, I read this tag, take a left. Or you have a forklift that might have an RFID reader and reads a tag in the floor that tells it to lower its boom because there's an overhead hazard. So you can see a lot of these different applications that you might see with some of these AGV, AGC applications. as well as load. Having an RFID reader on the AGV, not to do for guidance, but for load management. Hey, what package or what tote just came on? I need to read that information on board here, and I don't have the space for a scanner or image-based reader to actually read a label. So maybe you're just doing some load identification. Again, that's shipping and receiving, inbound, outbound, and then again to that long-range reads at very fast speeds. So kind of showing a train in the bottom right corner there. Done applications at 70 miles an hour doing a train ID. So kind of really see the range and the speed that you can really get with ultra high frequency. And again, just to final, just kind of highlight just one of the major applications you see quite a bit, again, with the Tote or RTI dunnage applications, being able to track and trace totes just on a conveyor. So very common logistic application, being able to write data to a tote or read data from a tote. And see small form fit functions, whether that's a side mount read or even embedding the RFID reader underneath the rollers themselves to do a bottom read to eliminate any kind of other mounting hazards you might have. So again, a very common application, short range, can be HF or UHF, depending on if it's an open loop or a closed loop process. But again, typically, obviously, a very dusty environment. There can be a lot of motion, fairly high speeds. I see a lot of these conveyors or totes going meter, 2 meters, 3 meters a second. So that's typically speeds that aren't usually an issue. Again, lighting is always an issue. So again, whether it's an image-based Tote reader, that might be an issue for doing any kind of Tote ID, where RFID will really kind of allow for a little more flexibility and reliability for Tote ID, especially those reusable tags that you might use. And again, compact design, looking for, again, very short range reads, but again, allowing for that capability now to have that pallet or have that tote leave from company A to go to company B. Because of UHF, because of rain, I'm able to actually track that tote or pallet or dunnage across enterprises now. So really it kind of opens up the world of I 4.0 and be able to do a real open process over the entire supply chain because of those global data standards there.
All right, Ryan. Well, thank you for the information today. We do have a few questions from the chat option that I can get to if you're ready for that, Ryan.
Shoot away.
All right, great. How much IT work needs to be done to implement an RFID system?
IT work. So as far as being able to implement as far as the actual hardware itself, you can get an RFID system up and running in minutes. As far as being able to wire up, power an RFID reader, start reading tags, like that's a very simple, quick process. As far as now integrating that into an ERP and network system, obviously there's a lot of security issues and whatnot, but on that side, it shouldn't be too much work. I'm not as familiar with that integration aspect of it. I'm more of on the serial side, the front end side of it, but I mean, it is global standards. It's as long as you can take in an Ethernet IP signal, we're OPC UA, Profinet. So as long as you're able to get take in that data output is very, very simple. You can get that data coming out very quickly. Obviously, the integration part into the ERP system might obviously a little bit more work on the IT side, but it should be, as long as you're able to take in a standard Ethernet string, should be pretty simple.
Okay, another question we received, Ryan, is about how you would manage privacy issues involved with using RFID technology, or what in general are the privacy issues?
Yeah, so RFID, so the tags themselves, you can actually lock or restrict data to the tags themselves. So there are capabilities of being able to, data protect or password protect your information on those tags. There's also capabilities of having like a kill switch, more or less. So you can send a kill bit to a tag and actually completely disable the whole thing. So you don't have to worry about anybody actually accessing the data that might be on that tag. So you do have those capabilities as far as password protecting that tag information, as well as being able to send a kill command basically to a tag and kill all the data on it. So maybe no one else reads that tag, goes dig it to the garbage or whatnot to, pick up RFID information. But yeah, so there is some password capabilities as far as, to protect the data that's on the tag themselves.
Okay, great. Another question we received is, can RFID tags be reused or reprogrammed? How would that work
Absolutely.
out?
Absolutely. So tags themselves are can absolutely 100% be reprogrammed or reused. We see a lot, especially for those higher dollar tags. That maybe those on metal tag on a car. Those they might be like $20 for a tag. Obviously, in the price of a car, that might not be a big issue, but maybe you want to reuse a tag that's on a tote. A tote goes through. I don't want to send that tote off with that tag. I want to reuse that. So bring it back to the beginning of the process, reprogram that tag, or rewrite information to that tag. So that's not an issue. The only limitation that you might have, and this would be per the tag specifications of the tag manufacturer themselves, is you might have a limit to how many times you can read or write data to a tag. Typically, that value is about 100,000 to a million read-write operations. So, quite a large number, but there usually is a limit to the read-write application or read-write process. But it typically ends up being hundreds of thousands to a million read-write operations if you are reusing it.
Great, thank you, Ryan. Another question we received is, will installation of a system impact day-to-day operations? And can you give an example of how that would work?
Impact day-to-day operations. It definitely shouldn't. Just like any other AutoID technology, obviously you're providing that track and trace visibility information. It definitely could, I would say, increase productivity, especially as far as, again, if something didn't get labeled, or if you are using a traditional image-based or laser-based scanner, you might not be able to, maybe a tag or a label forgot to be put on, whereas an RFID tag would always be read. Or maybe the orientation of a package might be oriented 180 degrees, and also the tag or the barcode's on the opposite side, or the reader can't see it. Again, RFID is not going to have an issue with that. As far as day-to-day operations, the ones I can think of right off the top of my head that we do quite a bit is airports and logistics in airports. We have a lot of RFID tunnels that we use to track and trace luggage as it's coming through, the whole checked baggage area. So I don't know if anybody has fly Delta. That's what I fly all the time. But if you actually go and grab one of your luggage strips at some point that might be on your checked bag, kind of peel it apart, you'll see an RFID tag actually inside that paper, that sticky label actually inside of the tray or the checked baggage tag. Again, why they use that is obviously you see a lot of 1D codes on there, but there's also using the RFID tag in there as well. So again, it really provides a lot of backup or redundancy to being able to make sure that you can read a tag or read a code in any orientation. So if anything, I'd say RFID is not going to impact any kind of day-to-day applications, but it is definitely going to supplement and hopefully increase productivity and a lot of these applications, reducing a lot of the misreads and reducing a lot of maybe orientation issues or lighting issues or environmental issues that you might have with traditional AutoID technology.
Another question we received, Ryan, is what advantages are there to using a mobile handheld UHF reader over a stationary UHF reader in certain situations? Can you list some situations where a mobile handheld reader would be better?
So obviously mobile handheld readers are, you're not tied to a stationary position at that point. So maybe you are doing so I see a lot of those mobile handhelds are almost like mobile computers. So maybe you want to use that to actually write information on the fly, or write data right to the tag itself via a mobile reader. So that'd be one of the things, obviously, being able to really kind of type in on a reader itself, hey, I need to send this information to the tag. I don't want to bring it to a stationary point to do that. So that'd be a good option for maybe a mobile reader itself. I would say if it's a stricter process, obviously a stationary readers would work out just fine, whether there needs to be a read-write information at that point. But I'd say mobile obviously is definitely going to give you a lot more flexibility as far as, you know, maybe the shipping and receiving aspect of it, where things are manually handled. But any kind of conveyor system or anything along those lines, obviously stationary would be probably preferred because there's not as much interaction, I guess, at that point with a human interaction at that point. So I would say shipping and receiving probably would be the biggest area that I would see maybe a mobile application or a mobile handheld unit being used.
Another question we received is, what are the maintenance or ongoing cost post-system installation?
Really the only thing at that point is whether or not you're reusing the tags themselves, or the tag maintenance. That would be the biggest thing. Is that tag being reused, or do you have to continually, you know, print off tags? The readers themselves, since there's no real moving components inside of there, you know, there's an antenna, so you don't have to worry about, you know, especially like a laser scanner, you might have a mechanical component that's spinning a laser dot, or image-based code readers where, again, maybe you have LED lights that might need to be replaced, or you have optics that you need to wipe off or clean every now and then because it's a very dusty environment. Again, UHF, you really don't need that direct line of sight to it anymore. So again, if it gets dirty, dusty, wet, it's not going to affect your read ranges, so you don't have any kind of physical maintenance on the device itself. I would say that really all the maintenance aspect you might have is, you know, obviously there's a tag cost. Tags are more expensive than just printing a label. However, tags are dropping in price, especially if you have a adhesive tag and you have an RFID printer, you're able to print, you know, maybe a RFID tag for pennies, you know, whereas obviously printing a label is much less than that. So there is a little more of a cost on probably the tag side, but as far as maintenance costs at that point, I think it would be actually less than any kind of traditional image-based or laser-based scanner, just because there's no, again, optics or lighting or moving parts that you have to deal with the with RFID readers.
Okay, great, Ryan. We do have a couple other questions or comments, and Ryan, I'll send those over to you afterwards.
Okay.
I also have on the screen now Ryan's contact information if they want to contact you as well. Ryan, I very much appreciate the information you gave us today. I think you gave a lot of people things to think about in terms of implementing an RFID solution, so we appreciate that. Also appreciate our audience for their active participation today. So Ryan,
right.
thank
well,
you
yeah,
again.
Thank you very much. Yeah, and yeah, send those questions over to me, and I'll answer the rest of them to the best of my ability. And if I can't, I'll find someone who can. So otherwise, thanks all for your time today, and glad I got you guys out at least a few minutes early here. So.
All right, thanks everyone. Appreciate your time today, and hope to talk with everyone soon.
All right, thank you.